this lesson, we're going to look at how we go between the name and formula for ionic compounds. First, we're going to look at ionic compounds that are formed from monatomic ions, metals which form a cation, and nonmetals which form an anion. For the metal, we don't have to change anything about the name. We leave it as is, so just the name of the element. For nonmetals, for nonmetal monatomic ions, we change the ending to IDE. Let's go through a couple of examples of how we deal with monatomic ions, and then we'll look at some where we're involving polyatomic ions. We always name the cation, then the anion, remembering that the cation is always first in the formula as well. When we look at RbBr, we have rubidium, which has the symbol Rb, and bromine, which is Br, so we change the ending to IDE. So we get rubidium bromide. Next, we have AlF3, so we have aluminum for the cation, fluorine is the anion, and we change the ending to IDE. Next, we're going to look at a couple of examples of ionic compounds that contain polyatomic ions. How do we know they contain polyatomic ions? Well, we look to see if there's more than two elements. And if we see that a compound has more than two elements, that's our indication that we should look for polyatomic ions in that compound. And the way we look for those polyatomic ions is going back to that list we learned and then seeing if we can match up what's in the formula with what we know. Let's look at NH4CN. In this case, we have four elements. We actually have two polyatomic ions in this compound. The first one is ammonium, and we don't change the name of that, and that's the cation. The second one is cyanide. That is the name of the polyatomic ion. We did not change the ending on that. So for polyatomic ions, we leave the names just as they are. Next, we have K2Cr2O7. Cr2O7 is a polyatomic ion. Potassium is a metal. We're going to name potassium. And then the name of this polyatomic ion is dichromate. Again, we do not change the ending of polyatomic ions. We use their names exactly as they are. So names of polyatomic ions are not changed in the compound's name. What is the name of AlCl3? The cation is always named first, so we have to look for aluminum, which means we can eliminate C and D as options because they list the anion first. Then we need to look at the name for chlorine in the compound, and we see that B has changed the ending to IDE, which is our correct answer. So for monatomic ions, we always change the name of the anion to have an ending of IDE. Let's look at some examples of how we go from the name to the formula. First, we have calcium chloride. Therefore, our cation is going to be calcium, so Ca2 plus. Our anion is chlorine, which has a charge of Cl minus, and we found those charges by looking at their locations on the periodic table because these are both main group elements. We crisscross down and get CaCl2. Next, we have barium nitride. This is nitride, not nitrite. This has an IDE ending, so we're just looking at the monatomic ion. Barium has a 2 plus charge. Nitrogen as an anion has a 3 minus charge, again, based on their locations on the periodic table. Crisscross down and get Ba3N2. In the last one, we actually have a polyatomic ion, sulfate. So we have K plus for our metal, SO4 2 minus for our anion, and we crisscross down to get K2SO4. What is the formula of calcium fluoride? Calcium has a 2 plus charge, fluorine has a minus charge, crisscross down and get CaF2, so C is the correct answer. When we're dealing with transition metals in a compound, we need to remember that they can have more than one possible charge as a cation. Therefore, the formula's name has to give something in there that gives us a clue to what the charge is. For example, copper 1 chloride and copper 2 chloride are both two different compounds with different properties. One of them, copper, has a +1 charge, the other, copper, has a 2+ charge. We use the Roman numerals in the name to indicate the charge on the cation. This is only for transition metals because they can have more than one possible charge. What is the charge on iron in Fe2O3? This goes back to what we did at the previous lesson of identifying the charge for transition metals. For iron, we label it X because we don't know what the charge is. Oxygen has a -2 charge in ionic compounds. We can set up our equation. 2 times X for the iron plus 3 times -2 for the oxygen. And we know those have to sum to 0 because it's a neutral compound. We get 2x minus 6 equals 0. 2x equals 6. So x equals 3 plus. Therefore, C is the correct answer. And we know the charge on iron in this compound is 3 plus. Same compound. Now we need to look at the name of that compound. What is the IUPAC name for Fe2O3? IUPAC is just the organization that determines the rules for naming compounds. We determined in the previous question that iron has a 3 plus charge, so C is the correct answer. Iron 3 oxide, the 3 giving us the charge on iron.